Dear students, welcome back to physics class. Today, the discussing topic is numerical related to errors in measurement. In previous class session, you studied absolute error, relative error, and percentage error, and also combination of these errors. For today's class, I am going to solve some numericals which are related to errors in measurement. Let me start. Question number 1 is, a physical quantity P is related to four observables A, B, C and D as follows. P is equal to AQ B square whole divided by root of C D. The percentage errors of measurement in A, B, C and D are 1%, 3%, 4% and 2% respectively. What is the percentage error in the quantity P? Solution is, given that A is equal to 1%, B is equal to 3%, C is equal to 4% and D is equal to 2%. And also given that P is equal to A cube B square whole divided by root of C D. Here square root is only for C. Then relative error in P is equal to P divided by delta P is equal to 3 into A by delta A plus 2 into B by delta B plus 1 by 2 into C by delta C plus D by delta D, which is equal to 3A by delta A plus 2B by delta B plus 1 by 2 C by delta C plus D by delta D. So, the percentage error in the quantity P is equal to relative error in P into 100%, which is equal to P by delta P into 100%. That will be equal to 3 into A by delta A plus 2 into B by delta B plus 1 by 2 into C by delta C plus D by delta D all into 100%, which is equal to 3 into A by delta A into 100% plus 2 into B by delta B into 100% plus 1 by 2 into C by delta C into 100% plus D by delta D into 100%. On putting the values of A, B, C and D, we get 3 into 1 plus 2 into 3 plus 1 by 2 into 4 plus 2 is equal to 3 plus 6 plus 2 plus 2 is equal to 13%. Second question is, if heat dissipated in a resistance can be determined from the relation H is equal to I square RT joule. If the maximum error in the measurement of current, resistance and time are 2%, 1% and 1% respectively, what would be the maximum error in the dissipated heat energy? In 10th grade class, you learned the joules heat energy. According to heating effect of electric current, amount of heat dissipated or lost by passing the electricity through electrical circuit or equipments, which is equal to I square RT. That is H is equal to I square RT. Solution is, given that H is equal to I square RT and also given that their percentage errors. For current, I is equal to 2%. For resistance, R is equal to 1%. And for time, T is equal to 1%. That is, delta I by I into 100% is equal to 2%. Delta R by R into 100% is equal to 1%. And delta T by T into 100% is equal to 1%. So, the percentage error in H is equal to delta H by H into 100%, which is equal to 2 into delta I by I into 100% plus delta R by R into 100% plus delta T by T into 100%. On putting the values of I, R and T, we get delta H by H into 100% is equal to 2 into 2 plus 1 plus 1%, which is equal to 6%. Here we got percentage error in heat dissipated is equal to plus or minus 6%. Third question is, given relative error in the measurement of length is 0.02, what is the percentage error? Solution is, we know that percentage error is equal to relative error into 100. Here, given that relative error in the measurement of length is equal to 0.02, then percentage error is equal to 0.02 into 100 is equal to 2%. So, percentage error in this measurement is equal to 2%. Fourth question is, the length of a rod measured in an experiment was found to be 2.48 meter, 2.46 meter, 2.50 meter, 2.48 meter and 2.49 meter. Find the average length, the absolute error in each observation and percentage error. Let me see the solution. Here, given that the measured values of length L1 is equal to 2.48, L2 is equal to 2.46 meter, L3 is equal to 2.50 meter, L4 is equal to 2.48 meter and L5 is equal to 2.49 meter. First we have to find the length. It is the arithmetic mean of measured values of length. So it is equal to L1 plus L2 plus L3 plus L4 plus L5 all divided by 5 is equal to 2.48 meter plus 2.46 meter plus 2.50 meter plus 2.48 meter plus 2.49 meter whole divided by 5 is equal to 12.41 divided by 5 is equal to 2.482 meter. Secondly, we have to find absolute error in each observation. The absolute errors are, for L1, delta L1 is equal to modulus of 2.48 minus 2.482 is equal to 0.002. Then delta L1 is equal to 0.002 meter. Similarly, delta L2 is equal to modulus of 2.46 minus 2.482 meter is equal to 0.022. So delta L2 is equal to 0.022 meter. Delta L3 is equal to modulus of 2.49 minus 2.482 is equal to 0.008. So delta L3 is equal to 0.008 meter. Delta L4 is equal to modulus of 2.50 minus 2.482 is equal to 0.018. Delta L4 is equal to 0.018 meter. And delta L5 is equal to modulus of 2.48 minus 2.482 is equal to 0.002. That is, delta L5 is equal to 0.002 meter. And last, you have to find percentage error, which is equal to relative error is multiplied by 100. Percentage error is equal to delta L mean divided by L into 100, where delta L mean means average value of absolute error or mean absolute error, and L be the arithmetic mean of all measured values of length or average length. Then mean absolute error delta L mean is equal to 0.002 plus 0.022 plus 0.008 plus 0.018 plus 0.002 whole divided by 5. It is the sum of all measured absolute errors whole divided by 5. Then it is equal to 0.052 divided by 5, which is equal to 0.0104 is equal to 0.01. So mean absolute error is equal to 0.01 meter. Then percentage error of the quantity is equal to delta L mean divided by L into 100 is equal to 0.01 divided by 2.48 multiplied by 100 is equal to 0.40%. So percentage error of the quantity is equal to 0.40%. Fifth question is, the error in the measurement of radius of a sphere is 2%. What would be the error in the volume of the sphere? See the solution. Given that percentage error delta R by R into 100 is equal to 2%. We know that volume of a sphere V is equal to 4 by 3 into pi R cube. So percentage error in volume is equal to delta V by V into 100 is equal to 3 into delta R by R into 100 is equal to 3 into 2% is equal to 6%. Here we have used the rule for combining arrays when a measured physical quantity is raised to power. Here the physical quantity is R cube. And also you have to see that 4 by 3 and pi are the constants which are inert. Sixth question is, if two resistors of resistances R1 is equal to 4 plus or minus 0.5% and R2 is equal to 16 plus or minus 0.5% are connected in series, find the equivalent resistance. What should be its solution? Given that R1 is equal to 4 plus or minus 0.5% and R2 is equal to 16 plus or minus 0.5%. When two resistors are connected in series, its effective resistance should be R is equal to R1 plus R2. Here, the effective resistance R is equal to 4 ohm plus 16 ohm is equal to 20 ohm. And you know that ohm is the unit of resistance and it is represented by a Greek symbol omega. To find the effective resistance, by considering the combining arrays, we have to use the rule for combination of arrays. Here, summation of two quantities are R1 and R2, then the effective resistance in series combination R effective is equal to R1 plus R2 plus or minus delta R1 plus delta R2. Since R1 is equal to 4 plus or minus 0.5% and R2 is equal to 16 plus or minus 0.5%. Delta R1 is equal to 0.5% of 4 and delta R2 is equal to 0.5% of 16. Then delta R1 plus delta R2 is equal to 0.5% of 4 plus 0.5% of 16 is equal to 0.5% of 20. So, R effective is equal to R1 plus R2 plus or minus delta R1 plus delta R2 is equal to 20 plus or minus 0.5% omega. Here we got the effective resistance is equal to 20 plus or minus 0.5% ohm. And last question is, if two resistors of resistances R1 is equal to 4 plus or minus 0.5 ohm and R2 is equal to 16 plus or minus 0.5 ohm are connected, first one in series and second one in parallel. Find the equivalent resistance of the A series combination and B parallel combination. Use for A the relation R is equal to R1 plus R2 and for B 1 by R dash is equal to 1 by R1 plus 1 by R2 and delta R dash by R dash square is equal to delta R1 by R1 square plus delta R2 by R2 square. Solution is, given that R1 is equal to 4 plus or minus 0.5 ohm and R2 is equal to 16 plus or minus 0.5 ohm. First one is series combination. The effective resistance in series combination R is equal to R1 plus R2, which is the equation number 1. Here the effective resistance R is equal to 4 ohm plus 16 ohm is equal to 20 ohm. By considering the rule of the combination of arrays, the effective resistance in series combination R effective is equal to R1 plus R2 plus or minus delta R1 plus delta R2. As R1 is equal to 4 plus or minus 0.5 ohm and R2 is equal to 16 plus or minus 0.5 ohm, then delta R1 is equal to 0.5 ohm and delta R2 is equal to 0.5 ohm. So, delta R1 plus delta R2 is equal to 0.5 ohm plus 0.5 ohm is equal to 1 ohm. So, the effective resistance in series combination R effective is equal to R1 plus R2 plus or minus delta R1 plus delta R2 is equal to 20 plus or minus 1 ohm. And second one is to find the effective resistance when these resistors are connected in parallel combination. We know that the reciprocal of effective resistance of two resistors when they are connected in parallel combination 1 by R dash is equal to 1 by R1 plus 1 by R2, where R dash be the effective resistance of two resistors R1 and R2. This equation is represented by 2. Then R dash is equal to R1 R2 divided by R1 plus R2. On substituting the values of R1 and R2, we get 4 into 16 divided by 4 plus 16 is equal to 64 divided by 20 is equal to 3.2 ohm. We have a delta R1 is equal to 0.5 ohm and delta R2 is equal to 0.5 ohm, and B delta R dash divided by R dash square is equal to delta R1 by R1 square plus delta R2 by R2 square, which is the equation number 2a. From the equation 2a, delta R dash is equal to R dash square into delta R1 by R1 square plus delta R2 by R2 square is equal to 3.2 square into 0.5 by 4 square plus 0.5 by 16 square is equal to 10.24 into 0.031 plus 0.002 is equal to 10.24 into 0.033 is equal to 0.33. So the equivalent resistance in parallel combination R dash is equal to 3.2 plus or minus 0.3 ohm. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.